Ken Forster, Executive Director at Momenta. Welcome to our Digital Thread podcast, produced by, for, and about digital industry leaders. In this series of conversations, we capture insights from the best and brightest minds in digital industry. They're executives, entrepreneurs, advisors, and other thought leaders. What they have in common is, like our team at Momenta, they are deep industry operators. We hope you find these podcasts informative, and as always, we welcome your comments and suggestions. Good day, and welcome to Momenta Digital Thread podcast series. Today, it is my great honor to have Prith Banerjee, Chief Technology Officer at Ansys, a leader in engineering simulation. Prith has a long track record of technology leadership roles, including EVP and CTO of Schneider Electric, Managing Director of Global Technology R&D at Accenture, EVP and CTO of ABB, and Director of HP Labs. In addition to an extensive academic background as Dean of Engineering at the University of Illinois at Chicago and Director of Computational Science and Engineering at the University of Urbana-Champaign, Prith is also an accomplished founder, founding AccelChip in 2000 and BINACHIP in 2006. He serves on the board of directors of Cubic and Turntide and numerous technology advisory boards. Wow, that is a mouthful, Prith. So with all of that being said, welcome to our Digital Thread podcast today.
Thank you very much, Ken. I'm looking forward to discussing this with you. Thank you.
I am as well. I must say, what an impressive record of achievements you've had, and across academia, large corporates, and certainly startups as well. So this should be a very interesting conversation. So I always like to start it off by asking about your personal digital thread. So in other words, the one or more thematic threads that define your digital industry journey.
Absolutely. So again, when people talk about digital thread in the sort of manufacturing industry, heavy industry like the world of ABB and Schneider, they talk about the fact that in the past, people used to build products, they designed products on a CAD tool, and then they prototyped their part in a lab. And then once they saw that kind of work, then they say, okay, let's try to sort of fabricate it at scale in a factory. And then they make the parts and they send out the factories to customers and so on. And there's no connection between what was imagined in the concept and then what was actually prototyped, what was manufactured, and what was operated on. In the new world of digital, right, with sort of all the digital technologies of cloud, mobility, IoT, analytics, et cetera, right? I mean, essentially, people are talking about the continuous digital thread, the thread from the CAD going through the simulation instead of doing sort of physical prototyping, doing hardware simulation, and then all the way to manufacturing through 3D printing and all the way to operations with IoT. So people are talking about the digital thread, maintaining sort of the connection from the CAD, the manufacturing, to operations in every phase in a life cycle. Personally, I have literally, in the last sort of 30 years, I have been working in different aspects of different digital technologies, first in academia, then the startup world, then the current worlds in industry, both in simulation companies and in large companies like ABB Schneider. So I have been part of this digital journey. And what I have observed is how personally I have become digitized, right? I use a lot of digital technologies myself, and how different aspects of my life, right? My world in academia, what I used to teach, how that has transferred into the world of startups and how that has gone into the world of large companies and so on. So I am personally practicing digital threads myself.
I just love this journey you've taken and the way you kind of laid it out as that digital thread from academic to entrepreneurial to corporate. I'd like to call you truly a Renaissance man in that regard. I also like Ansys' tagline. In some sense, I think it's almost your personal one in calling engineering what's ahead in that regard. Kind of looking back on the last 30 years, as you mentioned, if you had to summarize all that experience into three observations of technology catalyzed transformation, what would those be?
Yes, so actually I have literally personally gone through this journey, and I want to share my enthusiasm with all your listeners, right? And so when I was in academia, you are essentially solving futuristic problems, what I call Horizon 3 innovation, right? You are focused on basic discovery, basic science, and so on, right? And it's not a product-based research. You are thinking about what are the really tough problems to solve, right? So for example, when I was in academia, I was working on parallel algorithms for VLSI, computer design, and so on. We were thinking, hey, this high-performance computing thing would come in the future. And when you're designing these large electronic chips, people would actually run out of computing and they would absolutely have to need to do those kind of things. When I was publishing papers in those days, right, the year was 1980, mid 1980s. I mean, everybody say, hey, come on, our workstation is fast enough. You really don't need the high performance computing and so on. But that's what an academic does, right? You look at the future 10, 20, 30 years in the future and say, this is the problem that needs to be solved and let's try to solve it, right? But what happens as the output of an academic research is you end in the publications, right? When you get his peer-reviewed IEEE or ACM transactions paper and so on, you say, wow, that's great. And you graduate these PhD students that have like 10, 12 papers themselves. And that is sort of the output, right? The output is publications, patents, PhD students, fame, recognition. You could become a fellow of IEEE and so on. That's it, right? But then what I realized, right? I mean, when I was at Northwestern, I completed a DARPA-sponsored research project on the match compiler, right? And it had all these wonderful demonstrations and so on, right, to DARPA. And they said, hey, you need to commercialize it. Now, that really struck a chord. I said, what? Commercialize it? They transferred this to industry? And what I found was, again, this is sort of the value of depth that people talk about, right? So in academia, you stop at the publication, stop at the patent, and it takes a long time to take those initial ideas, the proof of concept, into a product, right, with all the user interfaces, so on, that people can actually use. Unfortunately, research funding, right, there's no research funding from NSF or DARPA or whatever to do that additional work. You look at startups that actually take ideas from an academic work, and this is sort of what I did in my personal life. I took leave from the university, started AccelChip, got some money from VCs, from Arch Ventures and Greylock and Intervest. And it took me sort of 2-3 more years to take those research ideas at Northwestern into a product. And then once that product was actually used by customers and so on, you evolve the product and you do a lot of things with it. And ultimately, AccelChip was acquired by Xilinx Corporation, which is where it showed up. That technology made it finally into a large company. And I've actually seen how large companies, the companies that I work for, ABB, Schneider, Ansys today, and so on, right? I mean, how they actually do a good job with respect to the Horizon 1 innovation, the Horizon 2 innovation, but they struggle oftentimes, right, with the Horizon 2, the 3s. And that's where the best thing for these large companies to do is to partner with the academia, with startups, and so on. And that has personally been my journey. You talked about the tagline of Ansys actually talks about engineering what's ahead. And the vision that we share with our customers is, in the old world, people used to do product innovations, right? By imagining a product and then coming up with a physical prototype of a product, which they prototype in a lab, right? And they tried 3 different things and they say, okay, this is the best one, right? Today, with really accurate physics-based simulation, what Ansys allows customers to do is to literally say, imagine, right? This is the possibility. If you had to do this kind of a wing shape and the fluid will flow over that wing shape, this wing, you don't have to test it in a wind tunnel, right? You can actually do it through simulation. So when Ansys Fluent says this wing will fly, it will fly. If it says at this angle, the wing will stall, it will stall, right? And so with the power of accurate simulation combined with sort of millions of processors that are available in the cloud and empowered by AI ML is enabling our customers to engineer what is ahead, right? Innovating in various industries like aerospace and automotive and high tech and manufacturing energy. This is how sort of I see my personal world, right, tie with sort of the mission statement of Ansys.
And I can certainly see how those align, again, to describe not only Ansys, but also your career trajectory, always engineering what's ahead. Let me ask a slightly different question. When I look at your digital thread, what I thought was interesting as well is your time in both enterprise IT and OT disciplines. And we, of course, looking at digital industry, always think very much on the OT side and how it connects in that IT side. Many have said that's a gap, right? The IT-OT gap. Given your time at ABB, Schneider, and Ansys and other companies, I guess, what's your perspective? You see a gap, and how has that gap changed over time?
Absolutely. There is a gap, and actually it is transforming as we speak. So let me sort of give you a specific example, right? So when I was at ABB is a large power and automation company, right? A $40 billion company. They had different divisions serving power, in high power, medium power, low power circuits, and so on, right? So they had these large transformers and switchgear and so on, right? Very, very large assets. And also they had things like robots and equipment. In the past, those assets, once they made those assets, they were imagined in a CAD world, right? They probably did some simulation, they manufactured it, and they shipped off that switchgear or whatever, or the robot into a customer location, and that's it, right? When that large asset failed, ABB had to send or repair people, right, to go and fix that thing, right? So they go in, they try to decode where the problem is, and they say, oh, we have that left coil has failed. So then the repair person goes back home and they try to find the replacement part. It takes 2 weeks, 3 weeks, etc. And that equipment is down for that time, right? That's no good. In the world of IoT, what has happened is essentially as soon as that breaker or robot or whatever fails, right, it calls home, right? So ABB essentially knows that that part has failed. And so not only with that, with all the diagnostics and so on, right, you can actually say, hey, this is what has failed. So by the time the repair person shows up, they actually bring the right parts to repair the thing, and it is essentially down only for a short time. And that was sort of, okay, IoT has enabled services. But where people are going with this, right, again, it's sort of creating digital twins and so on. They're doing predictive analytics. Before a large part fails, it actually gives signal it's about to fail. Just like when before we actually fall sick, we get a fever and we have more fever and so on. So as you are getting abnormal signals compared to the normal signals, if you can collect all the data through an IoT platform, you can do amazing things with respect to predictive analytics. And that's sort of where companies like Schneider, when I was at Schneider, we are building the EcoStruxure IoT platform, ABB with the Ability platform, connected up all those assets, right? GE with its Predix platform. This is essentially what has happened. So the IT-OT convergence that you talk about, right? Typically, sort of the IT companies like HP and Dell and so on, and IBM, right? They were working on the IT world, right? Or Accenture, right? They were working on the IT world, right? On the IT stack, on the cloud and mobility and so on. And the OT companies, the Schneiders and ABBs and GEs, right? Honeywell, they're working on the OT world, right? On the on-premise, in the operations, what is going on. What has happened these days is with various IoT platforms like Ability from ABB or Predix from GE or EcoStruxure from Schneider and Honeywell and everybody's platform, all these words are coming together, right? That's what is the IT-OT convergence. Now, the Ansys angle is we do simulation, and essentially what we allow our customers to do is to do sort of hybrid digital twins where the prediction of that predictive analytics that you do with pure data analytics we have found is kind of limited to about maybe 80% accuracy. If you can do it with simulation, it goes to about 90% accuracy. But if you combine physics and data analytics, you can get to 99% accuracy. This is the power of the hybrid digital twin, which is the intersection of IT/OT that I'm personally very, very excited about.
And you've really become a thought leader, not only on digital twin, but this idea of hybrid digital twin. Maybe just kind of reset, what does the term digital twin mean to you, and why should it be important to our digital industry focused listening audience?
Absolutely. Digital twin, basically people sort of the definition of the digital twin, right? I mean, Ansys is a founding member of the Digital Twin Consortium, and there are other companies like GE and Microsoft and Dell. They're all founding members. And so the first thing that we did was to define officially what is a digital twin. Now, to get to a digital twin, you need to have a physical asset like the transformer or the switchgear or the robot, right? Then you have to have a model of the asset. And oftentimes people sort of confuse a simulation model of an asset as the digital twin. What makes a digital twin is the third thing, which is two-way information flow between the physical asset and that model. So information flows from the asset to this model that makes it a little more accurate, and information flows from the model back to the asset through their IoT platform. And essential, therefore, what the Digital Twin Consortium has defined digital twin as, it's a virtual model of a process or asset which is synchronized at high fidelity and at certain frequency. So, this is a very short definition, but it means a lot because it's talking about the model and the model between the physical and the real. And it talks about the synchronization, the two-way information flow. And it says, so the synchronization does with a certain fidelity, right? So you can have a very rough, low fidelity model, which is also a digital twin, or a high fidelity model. And sort of the hybrid digital twin that I'm talking about really brings it together. So just to double click, right? So in the world of digital twin, people used to just come up with slap some sort of sensors to assets and collect data on those assets, and they built a digital model of that asset. It's a very general model, but the accuracy of the predictive analytics is kind of limited to the data you have seen, right? The Space Shuttle Challenger had an explosion, right? How many times did the Space Shuttle explode? Only once. So there's no amount of data collection that would have predicted a Space Shuttle would explode, right? Because you don't have enough data. However, with physics simulation, right, with Ansys tools or other simulation tools, you could actually model the fact that here's a space shuttle. It is entering the Earth's atmosphere at 15G. That is generating a lot of fluid flow over the tiles. That is generating a lot of heat. And the heat is going to make those tiles expand. At a certain point, the tile expansion will create force stress. The tile would explode and oops. And that's where the space shuttle may explode, right? So those physics-based analysis can be done only through detailed simulation. But you combine that with IoT. Imagine on that space shuttle, right? You had an IoT connection and say, hey, this is about to crack, this is about to crack. And you actually notice a crack which is 6 inches long, then 7 inches long. If you could synchronize that IoT connection, the actual connection, the real asset with some simulation where you say, hey, I'm going to do smart propagation, you can combine the two, you can do amazing, accurate results. This is where the future of digital twins is. And we have a twin builder product at Ansys, which actually does this in this vision that I talked about, the hybrid digital twin.
Wow, what a great definition there. And I like the double click down. That's really a relevant example. One of your peer companies, of course, in the space is PTC, who acquired ThingWorx back in 2013, which was one of our early portfolio companies. The deal rationale they had almost sounds like an early version of digital twin, and they were calling it round trip engineering from CAD out to the asset itself, right? Monitoring the asset. It's been almost 8 years since that acquisition. Do you think we're any closer to that promise at this point?
Absolutely. And in fact, PTC is one of our strongest, not just peer companies, partner companies. I was on a call recently with Brian Thompson from PTC only last week, right? So you look at PTC's original product. I mean, they were sort of the big thing that they do. They have this CAD tool, right? So when I talked about product innovation, you're imagining a sort of an aircraft wing or an engine or a gas turbine blade. You design it using a CAD tool such as Creo, right? And then essentially, once you imagine that, you essentially do a bunch of 3-4 different physical prototypes, which is how people used to do designs in the past, right? They do 3-4 different prototypes, and then they say, okay, this has been fabricated, and I'm going to sort of test it, manufacture it at scale in a factory, and that's it. It goes out in the field, and it's operating. Now, that was the old world. Then the world of simulation came in, simulation-based product innovation, where once you enter it in a CAD tool like Creo, you do a simulation of that, right? So you can do very simple, sort of quick simulation, and we have a tool called Ansys Discovery that ties in with Creo, right? So as soon as a designer is entering a new CAD design in Creo, they can do a quick simulation through Ansys Discovery tools, and the two tools are very tied together. But Discovery is sort of a very quick simulation called real-time simulation. But an analyst really needs to do detailed simulation. So we have Ansys Mechanical for structural simulation using finite element analysis, or fluid simulation, right, with Fluent, or electromagnetic simulation with HFSS. So we have those different physics solvers that are tied in, right, for doing the deep analytic simulation. Then once you go into the manufacturing area, essentially you can do sort of manufacturing with additive manufacturing like 3D printing and so on. Again, we have tools such as additive solutions that can simulate that 3D manufactured product. Then that product goes all the way to an operations, and then you connect it through an IoT platform. What PTC has, the second tool they have is this sort of PLM, product lifecycle management tool called Windchill, right? And so that manages that digital thread. But at the end of the thread is sort of an operations, and you're collecting data through an IoT platform. And essentially that is the ThingWorx platform that PTC had. So the partnership that we have with PTC is PTC does the CAD. We do the simulation, the quick, rapid simulation with Discovery, and the detailed simulation with Ansys Mechanical, HFS, and so on. But then this is more sort of managed by the PLM. And then at the end, you have the IoT platform, which is the ThingWorx platform. And then we essentially take the ThingWorx platform output, the PTC stuff, and then use that to build digital twins, right? The hybrid digital twin. So this journey of this digital thread, starting from concept to design to sort of manufacturing to operations, and that getting you feedback to the next product innovation is the digital thread. And this is how PTC and Ansys are kind of working hand in hand together.
You know, at the time we were involved in the transaction, the thesis really looked like this: PLM, ALM, SLM, all basically got you to, you'd say, this life cycle of design to delivery, right? I designed the product and I delivered off the back shelf of the OEM, if you will. What ThingWorx brought into this is this idea of monitoring that asset throughout its life cycle, right? And so you could put connected CAD, connected PLM, ALM, SLM, et cetera. And it gave a whole new valuation to that full cycle, such that you could look at the life cycle now of that equipment that was produced from design to really a disassembly at the end of life, right? Really thinking long terms. And it was very interesting looking at those models and those economics in terms of the difference that it made. So I agree with you. It was a pretty wise investment on their part. And it seems to have really proven, together with the work you're doing at Ansys, how this can really truly be round trip, right? The dream for many a generation.
Absolutely. And where they're headed is sort of now the world is moving to the cloud, right? And so essentially they have now acquired a company, Onshape, right, which is CAD on the cloud. And again, we are doing some amazing work on sort of simulation on the cloud, right? So essentially this journey on the cloud is we're going to continue to partner with PTC in this area.
Perfect. You mentioned innovation earlier in this idea of Horizon 1, 2, and 3. I'd like to drill down on that a little bit. And just so the audience knows, number one is Ansys was named to Fast Company's annual list of 100 best workplaces for innovators, right? That's quite an interesting one. You, of course, have had a lot of experience in academia, so UIUC, Northwestern, startups, AccelChip and BINACHIP, and large companies, HP, ABB, Schneider, Ansys, et cetera. I guess looking at one, why Ansys got that award, and two, your broader perspective of best practices in corporate innovation, outside in, I guess, in some sense. What would you say are some of the interesting best practices that you've seen out there?
Absolutely. So again, this topic of innovation is very, very close to me, and I'm very passionate about it. As you mentioned, I've been fortunate to have worked in sort of three completely different fields, right, of innovation. I mean, people are thrilled if they can just work in academia. And I was in academia for about 20 years, working for both public universities, like University of Illinois, and private universities at Northwestern, right? So what academics do, and this is kind of where I started when I started the interview, right? They do a phenomenal job in the Horizon 3 innovation, the sort of 5, 10 years, 15 years out, right? Funded by the National Science Foundation or DARPA, whatever. They're imagining what is the possibility, right, out there in the future world. But those professors and graduate students, they do all this fantastic work and they submit, once they're done with the research, right? They publish this amazing work in a peer-reviewed conference or a journal, IEEE conference or a ACN journal. And that's it, right? Because the metrics of promotion and tenure and whatever in academia sort of says, okay, you found the new stuff, right? You've innovated, you've solved the problem. This problem was, how do you do a really scalable sort of database that can scale up to 2 trillion data, etc. And that's it. You publish the paper, you're done. What I have found is it takes a lot of work to take those ideas that were essentially written up in a publication, right, to convert that into a product, right, that customers would use. And in my personal journey, right, when I ended the sort of match compiler work at Northwestern, DARPA sponsored, right, amazing, really futuristic technology, taking MATLAB programs and automatically generate chip designs, right, using VHDL and so on. It looked really good, but it was not a product. So essentially at that point, I took leave from the university, from Northwestern, and founded AccelChip, right, raising money from VCs and so on, and build that product. Now, that building that product took about a 2-year period, and was very focused on just building that product, MATLAB in, registered transferable VHDL out to be mapped on FPGAs. And then you work with customers and, well, this doesn't work, etc. So there's a lot of work that is needed. And sort of VCs sort of come in at that point, right? Taking that idea, a very focused product, and building that product, and which was sort of a disruptive thing industry in the time around 2000, etc. Right? And then AccelChip, after 4 or 5 years, was acquired by Xilinx Corporation. And that became part of the portfolio. Xilinx makes FPGAs, and they were building design tools for FPGAs, so it wasn't part of this thing. Now, the observation that I have made is that large companies do a fantastic job in the Horizon 1 innovation, which is they have a current set of products. They're building FPGAs or breakers or panels or whatever from ABB, or Ansys has our tools on simulation tools like HFSS and Maxwell, right? So they do a good job there because they have an existing product. They're interfacing with customers. The field tells us, oh, we need these features. Your competition is doing this. So they do a fantastic job in the Horizon 1 innovation. Horizon 2 is the adjacency, right? You have these things, okay, now I need to go on the cloud. Maybe I should do this, etc. Maybe this thing is working for sort of the North America market, right? I have a breaker for North America for 110 volts. I now need to go to China for 220 volts. That also they do a good job, right? Where they struggle, large companies struggle, is in the disruptive innovation, right? The Horizon 3 innovation. I don't have a product in that space, and I'm just imagining a product. And so companies, again, I worked at HP Labs, and when I was at HP Labs, I was helping HP build those disruptive innovation, right? The Horizon 3s and so on. But even if you build a really interesting product in your lab, the large companies, sales forces really don't know how to sell their product, right? So it's, oh, I don't know what to do with, right? So there is a challenge. So essentially, the observation I'm making is that these large companies, in order to do disruptive innovation, they need to have sort of a central arm for R&D, and then that central arm needs to do partnerships with universities and startups and bring those startups technology as part of this. So now what am I doing at Ansys, right? So at Ansys, I am leading efforts in AI, machine learning applied to simulation. So we have an organic group. We are doing some amazing work with AI/ML. But in addition to the organic work, we are also working with academia, right? We are working with professors at Stanford, at Carnegie Mellon, at Princeton, at Brown, and so on, and taking those really research innovative ideas and working, sort of cooking it jointly with the work that is going on at Ansys. And then we are also working with various startups. Now, I don't want to actually name the startups here, but we are working with a set of startups, right? We are taking those startups' ideas and combining that with our stuff and doing some amazing stuff. And it's just, that's, for example, the work that we're doing AI/ML. We are doing similar work in digital twins, similar work with HPC. So the observation is that large companies, they will be successful with Horizon 3 innovation if they know how to work with startups and so on. And through the startups, what we have done is we initially work with the startup, then we invest in the startup, then we acquire the startup. For example, right? I mean, 2 years ago, we worked with a startup called Denardo that had a tool called OptiStank that was allowing our customers to use our simulation tools and do design of sort of optimization around it, right? So we initially had an OEM agreement with the startup. Then we invested in the startup. Then we actually bought the startup Denardo, right, in 2019. And over the last sort of 50 years, Ansys has acquired 26 companies, right? So this is how we are essentially doing this Horizon 3 kind of innovation, where we see all these possibilities, bring those technologies and integrate the technology, and then essentially bring them to our customers. And that is what has allowed Ansys to win this Fast Company Award for Best Innovators. And one of the things that we do internally at Ansys is to have these CEO Innovation Awards, right? We have 3 sets of awards: awards for the most innovative product, the most innovative solution, the most innovative technology. And that has changed the culture at Ansys. So I'm very happy to be talking about innovation at Ansys with all of your listeners.
You clearly have a lot of passion around this space and clearly a track record that says you know what you're talking about. So maybe we can expect a book here from you in the future on this great topic, because it would be very, very timely.
Actually, Ken, strange you mentioned this. I'm writing a book called Innovation Factory. It should come out hopefully by the end of this year or early next year. And essentially, it is about how large companies can innovate in the 21st century, right? By better partnering with universities and startups. And every large company, they say, oh, yeah, I work with university. I do some funding, right? Oh, I work with startups. But the thing is, I mean, you can do those kind of work as a checkbox, or you can actually do it. So my book is going to talk about practical guidelines as to what I have learned and being on the receiving end of sort of company funding at the University of Northwestern. And I've sort of funded research when I was at HP Labs, and I worked with startups. So I've sort of seen what works, what doesn't. And that's sort of my contribution to society. Hopefully, your listeners will read my book on Innovation Factory 6 months from now. Thank you.
Excellent. Wow. I will be one of your first readers. So definitely let us know when that is published. Given all this discussion around innovation, and again, this tagline of engineering what's ahead, I'm going to ask you to put your prognosticator hat on and tell us, what 3 trends do you think will define the next 5 years for the industry?
So, I mean, obviously, it's very hard to predict the future, right? But a few things that I am seeing is AI and machine learning is going to be extremely, extremely important to the world in general. And we at Ansys really looking at sort of the use of AI ML applied to simulation. So how are we doing this? Well, we are trying to use it to improve the customer productivity, use of our tools. I mean, augmented simulation, how do you simulate things much faster, etc. So AI ML is clearly disrupting a lot of the things in various industries with recommendation engines and this and so on and so forth. But it will completely change the way that the world sort of goes through and so on. The second thing is sort of access to tremendous amounts of computing and storage, right? I mean, essentially, people do these things on workstation, they have HPC clusters and so on and so forth. But you look at all the cloud providers, right? From Amazon, AWS and Azure and Google Cloud Platform and IBMs and so on, right? And Oracles. All these cloud providers are providing tremendous amount of compute, right? On their resources. So essentially, this is going to transform the world of sort of simulation-based product innovation, because in the past, you were limited Well, I want to do a finite element analysis. I mean, I don't have as much computing power, so I limit it to only 1,000,000 mesh points. If I had 1,000,000 processors, I could go to 1 billion mesh points. I could do 1 trillion mesh points, and don't worry about the accuracy. I could be as accurate, more accurate than the physical world, right? So essentially, the cloud and the sort of HPC on the cloud is going to be a very, very big disruptor, right? And you can always already see all of those. And the third thing that I see is sort of the world around ecosystem. And that ties in with this whole concept of open innovation that I was talking about, right? I mean, a company by itself cannot do all the work itself, right? You look at the automotive industry, right? I mean, there's fundamental things are happening in electrification, autonomy, and whatever, right? But the car companies, the Fords and the GMs and BMWs, right? They cannot do all that innovation themselves. So they rely on the suppliers, the Bosch, the Continentals, and so on, right? They'll do this really interesting thing to feed into that process, right? So the question is, how will innovation happen in the future? And I believe it will happen through an ecosystem where you enable third-party developers, right? So suppliers, developers, and so on to co-innovate for you some really interesting parts, right? And within our own sort of little field of simulation, we are sort of thinking around, okay, how do we enable third-party developers in innovating, right? Very, very interesting things by using sort of Ansys solvers in the back end and so on. So anyway, those three things that I kind of talked about, AI, ML, cloud sort of enabled with HPC, and sort of this whole world of APIs and third-party developers and so on ecosystem. Those are three, I think, very, very interesting trends to watch for.
Yeah, I would fully agree. I like the fact that you've coupled two technologies with one social pattern, and we are seeing a lot more of this. Is even if you look at the EU's Industry 5 initiative, it's coupling the technologies of Industry 4 with resilience, social good, environmental, et cetera. So it's pretty interesting to see, in terms of how we go about doing something may be important as what we do in the end. And I like this ecosystem concept. So finally, in closing, where do you find your inspiration? Think books, people, et cetera.
Absolutely. I mean, I read a lot of books. I mean, fortunately, with all the digital things that are out there, right, you don't have to read physical books. I mean, you can go online and get amazing sort of readings and so on. I listen to the radio, listen to podcasts such as yours, right? And just looking at sort of amazing leaders, innovators, right? Wonderful people that I get inspired with. So it is a combination of all three, right? Sort of the podcasts, the online readings, the books, and the people that I see. And just obviously people like Elon Musk and Jeff Bezos, just absolutely really, really wonderful sort of role models, right? For all of us to kind of emulate and follow.
Yeah, clearly, speaking of ecosystem, it sounds like you've got a wonderful ecosystem of inspiration. So, well, Prith, thank you for sharing this time and these wonderful insights with us today.
Thank you very much, Ken. Really appreciate it.
Oh, as well. So this has been Prith Banerjee, CTO of Ansys, a man and a company focused on engineering what's ahead. Thank you for listening, and please join us next week for the next episode of our Digital Thread podcast series. Thank you, and have a great day. You've been listening to the Momenta Digital Thread podcast series. We hope you've enjoyed the discussion, and as always, we welcome your comments and suggestions. Please check our website at momenta.one for archived versions of podcasts, as well as resources to help with your digital industry journey. Thank you for listening.